Now we will see the second application of Hamilton's equation of motion, that is nothing but compound pendulum. So we are going to derive the equation of motion of compound pendulum using Hamilton's equation of motion. Okay, so here generally how the compound pendulum is appearing, so it is like this. It is like a bar, iron bar, and it is having some number of holes. Okay, so when you move this compound pendulum to a certain distance, what happens is its length must not be moved. Okay, but this moves in the angular separation only. Okay, so now this will be the L cos theta. So to solve the equation of motion, what we require? First we require equation of motion of Hamilton's equation. Let us consider the first equation of motion of Hamilton equation, dH by dqj. Now this is also we are considering in terms of angular separation. So here the generalized coordinates are thetas. So this equation becomes minus p theta dot is equal to dH by d theta. So let it be equation 1. Now next step, why we want h is equal to Hamiltonian's function pj qj dot minus L. Now h is equal to, what is pj here? So p theta and q, instead of q we want theta dot minus L. Let it be equation 2. Now next step we want L. L is equal to T minus V. So here what is the kinetic energy of the compound pendulum? Here the kinetic energy of the compound pendulum can be written as half I theta dot square, because this is the angular velocity theta dot half I omega square. You know this formula. So I is the moment of inertia. Now what will be the potential energy? That is equal to mgh, and that height can be considered as L cos theta. Okay, so L minus L cos theta. So potential energy can be written as minus mgl cos theta. So here we are not, there is no much change in the length, so we cannot write L minus mgl cos theta. So this is the minus mgl cos theta. So L is equal to half I theta dot square, minus of minus is nothing but mgl cos theta. So L function we got equation 3. Okay, now next step is we have L value but we want p theta. So to get the p theta, what is the formula? Dou L by dou theta dot. So here if you can write dou L by dou theta dot half I theta dot square plus mgl cos theta. So here we can write half I into 2 theta dot, that is equal to I theta dot. So what we got instead of p theta? So p theta is equal to, we got I theta dot. So let it be equation 4. So now if you can substitute 3 and 4 in equation 2, then h is equal to I theta dot minus half I theta dot square. Okay, so minus mgl cos theta. So that is equal to, we will get half I theta dot square minus mgl cos theta. So that is h function we got. Okay, let it be equation 5. Now consider equation of motion of Hamilton's equation. Okay, so then what is the equation of motion? Minus p theta dot is equal to dou h by dou theta. So minus dp theta by dt is equal to dou by dou theta of what is h value? I theta dot square minus mgl cos theta. Okay, so minus d by dt of what is p theta we got? I theta dot is equal to, so here there is no theta term here. So then minus mgl into minus sin theta. So we got I theta double dot is equal to plus mgl sin theta. Now as usual, if sin theta is very small, instead of sin theta we can write theta. So minus mgl theta. So I theta double dot plus mgl theta is equal to 0. Theta double dot plus mgl by I is equal to mgl by I into theta is equal to 0. Now this is the equation of motion of compound pendulum. Now what will be its frequency? Omega square is equal to mgl by I, and omega is equal to square root of mgl by I. Okay, so this will be the angular frequency, and if you want to write the frequency 2 pi f mgl by I, f is equal to 1 by 2 pi into mgl by I. So hope you have understood. So in the compound, what are the main things here?